Yeah,
Oh, wow.
Still working in Seattle. In insurance.
Okay.
Marine insurance.
Yes.
Nebraska. My daughter couldn't get to that.
One of the recent studies showed
we
that it
actually
really
just
wasn't
were-
there.
that's what I
Demonstrated and going to San Diego.
Yeah.
It seems like going to San Diego.
Yeah, it's in the middle of the.
I just got a bad, mental connotation. Growing up in California, I just thought, sure, Nebraska blizzards.
You're a bi-coastal guy.
It's just not on my radar.
You're blue, you're blue.
Let's settle down. Yeah, it's the first time we drove into Italy.
Oh, sorry.
Had a big
Just gonna make some meaningful comments here, so Travis can check the audio. Make sure we have full audio.
last year.
The other comment, Al Kraus, if you're listening,
Check in.
yeah, we're checking on you. It's been the longest time we haven't seen you here. And we're getting to the population here that's just fellows, faculty, or old people. That doesn't, not the pharmaceutical people, but the health people. So we can't lose too many old people. Certainly,
Well.
Gary showed up today. Ari and Drew are on vacation. We have too liberal vacation policy here.
The Grim Reaper will come for all of us.
So anyway, hopefully that's enough of just background comments that Travis can tell me if he has audio. Or we have good audio. So today's speaker was supposed to be rheumatology for allergy, and the guy who was supposed to be the speaker contacted me on Thursday, didn't explain himself, just said he wasn't going to do it. So through the weekend, I'm trying to get a hold of him, figure out what's wrong. Finally, yesterday he gets back to me, and he's going to switch out and do the day that Matt was originally assigned. So thankfully, Matt was willing to move his talk up to today and talk about available and emerging biomarkers as tools to identify asthma phenotypes. And thank you for filling in, Matt.
Yeah, I was also going to comment on the sparks attendant, but we've got hardcore people here, so that's what's important. And I saw at least we had names splashing up of who's called in, so we have a few. I saw Sally. So welcome to the outside world. Yeah, I've talked about this a few times, and I kind of merged together some slides last night. So I don't know the order of them, but we'll sort it out. And, I'll talk about biomarkers. I think in terms of, it's obviously all in reference to biologics. And frankly, we've had the people who ran the New England Journal biologic studies out here this year, so I'm not going to try to explain their studies better than they did, but use them really as a reminder for where we are, how it lends itself to the use of biomarkers and endotypes and all that. And please just interrupt as we go. This can be a discussion. I'm just funded by the NIH. So, what we'll try to talk about are what are the key immunology pathways driving asthma. Of course, we all know something about T2 inflammation, but thinking about what do we really know about that and what do we know about other pathways. Discuss this idea that has been prevalent in the literature for over a decade of endotypes and how it relates to the clinical phenotypes, and then talk about biomarkers that we have, how to use them, and then research into new biomarkers. And if you were at my Quad AI talk, I started with this, the idea that science in a movie looks like this. Take your favorite movie, but we make some discovery and we're advanced. But in reality, it's not that at all. We learned something, we realized we were completely wrong because of some technical issue, we learned something more, there's a flat period, there are ups and downs, right? And, a lot of the things we thought we knew turn out to be wrong or turn out to be more nuanced or what have you as we slowly make progress. And that's really true for asthma as well, right? I mean, I'll talk you through some examples, but the eosinophil is a classic one of our understanding, lack of understanding, and then new understanding. So everybody knows what asthma is. I won't dwell on this, but I just want to point out that it's a syndrome, right? It's not one disease by any stretch of the imagination. And it's a syndrome that's clinically characterized by inflammation in the airway and bronchoconstriction, reversible bronchoconstriction. And so in it being a syndrome that we've just defined clinically for decades, we really need to sub-parse it into multiple sub-diseases, or parse it into sub-diseases. And it's really, many different etiologies, different pathophysiologies, which manifest as different sort of sub-phenotypes, and again, different triggers, different mechanisms. And, we hand wave and say, well, it's a combination of environment and genetics, and we're sorting all that out. So by way of definition, right, phenotypes are what we see in clinic. I think everybody knows this. The technical Webster's definition is up there, basically the properties of an organism that are produced on a macro scale by genotype environment, and it's all that heterogeneity. So some people have severe, have fixed lung obstruction, some don't. Some have, extreme sensitivity to one thing and not another. And an example, so it's, that low FEV1. Whereas, the endotype idea was sort of coined, and I don't know if Sally is the one who coined it or exactly how it came about. And it's actually not the greatest term. What we probably should call it is a molecular phenotype or a molecular mechanism. But that's basically the idea behind it, is what is the actual molecular pathway, be it at a cell level or a protein level or whatever, that explains the observable properties of a disease. And I mean, ideally they would line up, right? All Th2 asthma would look like one thing, and all eosinophil asthma would look like another. In reality, that's not true. There's a lot of, crossover. We can't line up a phenotype to a single endotype, but the idea is that they inform one another. And so, of course, Th2 inflammation, or T2, is what we think of. So just to drive this home, I got a whole hour to fill here. So you've got phenotype characteristics up there, and then endotype you can define at different levels. So there's you could say, well, eosinophilic or neutrophilic is an endotype. Although we really want to drill deeper and say, all right, not just that, but okay, IL-5 driven or IL-4, and right now we know about these pathways, but we really don't actually know who's a responder to anti-IL-5, who's a responder to anti-IL-4 receptor, so on and so forth. And we really do need a lot better studies to parse out those submolecular mechanisms to inform which drug is most appropriate for which individual. So why do we care? Well, it's because, exactly as I've alluded to, it gives us targeted treatment approaches. I mean, the age of different steroid inhalers is dead. I think we all know steroids work. They all work about the same. And we have to think about more personalized approaches. And a major unmet need is exactly that. So especially on the most severe spectrum of asthma, but in asthma writ large, right? We'd really like more specific treatments, specific to individual. And it allows us to understand who's going to benefit from a particular therapy. And perhaps most importantly, right, I mean, again, you can take the IL-5 story that I'll walk through in a minute as a perfect example. If we don't think about this, we can't run good clinical or translational studies. Because if you just take all comers asthma, you're going to have a few that are in your pathway of interest, but you're going to have a lot that are not, and you're going to have bad data. So we really need to use these to think about how we design clinical studies. So backing up a little bit, how did we understand the first endotype of asthma, so to speak, or what, the main pathway we think of, T2. So this, of course, predates me by a lot, and actually, predates all of us, really, if you think about the atopic triad, right? This has been recognized for a long, long time, that you get these things together. You get atopic dermatitis, you get allergies, and you get asthma. And I didn't know this. I sort of just, kind of come into a specialty and you assume everything that's known has been known forever. But the idea that the T2 cytokines are driving it really is only from, the first proof in humans was from 1992. Yeah, there was a lot of mouse data before this, but it's Barry Cade's group in the UK that really showed for the first time, they basically took, in retrospect, this is a very simple study. You just take BAL fluid from asthma and healthy, and you measure mRNA, specifically from the T cells from BAL. And what they showed was basically there were higher levels of these now, what we think of as canonical T2 cytokines, like IL-4, IL-5, IL-3. This was before we really knew about IL-13. And it's higher in asthma than healthy. And obviously there's a range there, and these people were selected to also be allergic, so it's not all asthma, but this is what put in our mind the idea that asthma is a T2 disease. And it's only been recently that we've, really begun to recognize, well, yes, it is for some people, but not all.
That's not our Dave Robinson down there, is it?
No, it's not.
From the UK?
That's from the UK. I don't remember that person's first name, but so anyway, so that's sort of, where we got the idea of Th2 asthma. So I think, the way I presented this at Quad AI, I said, all right, well, there's T2, but then, shortly after that, or, even as this was done, people knew that the eosinophil was important. It seemed to be a marker. You see high eosinophils in asthma. And what Sally Wenzel did in a paper in 1999 was show that some people with asthma have high eosinophils, some don't. It doesn't, so what this figure is showing over on the left is the level of eosinophils in this case did not distinguish, mild versus moderate disease. But what they did show was, first off, just on average, asthma has higher eosinophils than healthy, normal. But specifically, you can subdivide people with high eosinophils or people with totally normal eosinophils. And in this case, if you think of that as an endotype or a mechanism or whatever, it actually does stratify by phenotype. And this has actually held up very robustly over the years. Basically, they showed that those with high eosinophils in this case have a higher rate of severe exacerbation, so intubation in effect. And that still holds true. We now think of high eosinophils as a marker of exacerbation prone. So they're very clear, good, and I think I'll show one later, linear correlates that the higher your eosinophils are, the more exacerbations you have per year. And so in that case, it is a good marker of a certain characteristic of asthma. So, there already we had recognized a biomarker, and I think, I don't really know the history, I wasn't around, but I think this concept got lost a little bit as the first IL-5 studies got underway. So, sort of from all that, we got our, Sally writes all these things, so I'm just going to use all of her studies. This is one of her Nature Medicine reviews. Our reductionist model of T2 asthma. And I think people like these cartoons. They help us think about things, but, they're also completely wrong. Because nothing is this simple, right, in biology. Never this easy. You can extract from a bunch of mouse studies and some human data and say, this is everything. But of course, it's not even close. But nevertheless, it does give us, key things to target, and so we try targeting things. And of course, the first biologic came out of this. Namely, we said, well, allergy is important, IgE is important. Why don't we block IgE? And it kind of worked. I don't think it worked for the reason that people think it works, but it nevertheless has done something to mitigate asthma exacerbations in certain individuals. And we'll kind of come back to that. What do we really know about anti-IgE? So anyway, first biomarker is IgE. or aeroallergen sensitization, the first target for that is omalizumab from, that's 15 years old now. So speaking to that point of though, Th2 is not all asthma. I think, this was really first clearly promoted by Prescott Woodruff at UCSF from this paper in 2009, where he basically said, let's take a bunch of people with asthma and some healthies, and let's look at their airway. And he did this a few ways. In this case, this heat map is showing gene expression after IL-13 stimulation of bronchial epithelial cells. And he showed that some people with asthma over on the left have a clear response to IL-13 in these genes he described, and he found these genes through an unbiased analysis approach, so it's not as though he was cherry picking. But he also said, well, but there's another half of these people with asthma who are indistinguishable from healthy, and these people were allergic. So, allergy is not a perfect correlate to T2 asthma. Basically they said, well, okay, yeah, there is T2 inflammation in asthma, but it's person-to-person specific. So basically the take-home from this was actually there's this T2 low group, and it's not just a T2 disease. And he showed, this is where we got our idea of periostin, and we learned a lot about what periostin is, and we'll talk about that as we go on, but it turns out not to be the biomarker currently that we hoped it might be. But in addition to that, he showed, this lines up with our canonical T2 cytokines, specifically IL-5, IL-13 being elevated in mRNA and biopsies from, so the red over here is the same as these guys over here. So you have high expression in response to IL-13, you also have IL-13 and IL-5. This is very sensitive advancing. And then same thing that, on average, those are the people who have eosinophils, although not exclusively, right? Some of them clearly don't. And this gets to the point that T2 and eosinophilic inflammation are not one-to-one aligned. And in the low, there are, perhaps some who have modestly elevated eosinophils. It's a small population. Again, going back to the idea of endotypes and phenotypes, what he did not find, or what, basically he could say that T2 high and T2 low look different in the airway. So when you histologically look at them, again, you see more eosinophils, you see more fibrosis, more different mucus, more sort of thick mucus in those T2 high. But when you just look at them clinically in your office, they're not really different by FEV1 or sort of other historical things. So in this case, we really, that's why we need biomarkers. You can't just identify these people by talking to them. So that, again, the idea of not everything is T2. So let's just, I'm jumping around a little bit, but let's go back to the idea of, well, what about T2 and what about IgE? So that's omalizumab. And I think everybody's aware of this, but there are some nuances at the end of this slide that I'll remind you of, right? So we use this specifically in those with elevated IgE, 30 or above. And you have to have some level of aeroallergen sensitization. I don't actually know that the drug's ever been tried in people who are non-allergic, certainly not in a large study that I'm aware of. But there may actually be some people without allergy who could respond to this. But nevertheless, those are what we think of as the biomarker, so high IgE or high, or some marker of being allergic to an aeroallergen. And with that, it's pretty effective, right? It decreases exacerbations by about half, decreases steroid use, all this great stuff. That's why we use the drug. But I think everybody here knows that it might work, it might not, right? It's not as though everybody gets better by 50%. It's that some people get a lot better and some people get no response. And the problem is we have no way of identifying those people currently. Because basically, while IgE is necessary, or we think it's necessary to indicate you might respond, the level of IgE, that's what's down here at the bottom, really has no prediction, no predictive value. So, and there are a lot of papers showing this. This was just a recent one from 2019 that I pulled, and it's actually not on this plot, but they also show in the paper that basically the IgE level, the eosinophil level, the pheno level, none of them predict whether or not you're going to respond. That's what's shown in the gray bars here. So basically, high eosinophil, low eosinophils, there's sort of equal likelihood of response, high pheno, low pheno, and same with high IgE, low IgE. So it's a poor biomarker. It's a binary biomarker as opposed to having some sort of continuous value metric for responsiveness.
Question. Like they correlated the IgE level, but we know like we are actually using it for specific IgE based on our inclusion criteria, right? We're saying they have a positive skin test for an allergen and they have some IgE, but what we are actually looking for based on these two criteria is that they are specifically allergic. Has anybody correlated the specific IgE level with response?
The level of a given specific IgE?
Yeah, I mean, we are using it most of the assays. They have the allergy to dust mite, right?
Yes.
Isn't
So
that
if you have
what
a higher specific IgE to dust mite, you're
Will you-
more likely to respond than if you have a low,
anybody tried that?
yes, that has been looked at. The place that where I think this may break down is the number of sensitizations. I'm pretty sure there's decent data that if you have numerous aeroallergen sensitizations, you're more likely to respond than if you have one. But I would suspect, it's been a while since I looked at those studies. That's not here. I'm not sure how robust that data is. But the actual level of IgE has been, be it total or specific, has no predictive value.
That's no predictive value.
Yeah.
But the number of sensitization,
Yeah.
probably.
Number of total sensitizations.
But there could be other biomarkers that are just haven't been evaluated. I mean,
Oh, of course.
I mean, for like tryptase could be, maybe it's affecting mast cell function or
Absolutely.
the density of the the specific IgE receptor or.
I'm sure there are good biomarkers for this, and nobody's taken the time to discover them. That's one of the problems. We have these drugs, and then there's no follow-up of how do we, and you're doing that now with chronic urticaria, and that's, it's good that we're doing that. Those are the sort of efforts we need. I'll get to it towards the end, but, this affects interferon response. So a lot of people think, all right, well, should we be looking at something about the interferon responsiveness of the individual to determine whether this drug will be useful or not? So those are the studies that have to happen. And the problem, I mean, there's just the motivation goes down, I think, to run those studies after it's FDA approved and everything.
Have you looked at like a differential gene expression in the inner city asthma cohort that got omalizumab?
Not with omalizumab. So that's what we're doing with the other biologics currently. We hope to go back and do it with omalizumab as well, but for a variety of conflict of interest among drug company reasons, we're not making comparisons right now. So
Does omalizumab reduce eosinophils as effectively as our new eosinophil drugs?
no,
It does reduce eos, though.
it does. I mean, I can't tell you exactly how much it does decrease them, but it certainly doesn't drive them down to zero. And same with the IL-4 pathway, it doesn't drive down eosinophils in the same regard, the same way. And actually, Bill, so actually to your point, I should go back. I haven't done any omalizumab work. Michelle Gill at Dallas did. So in the inner city asthma study ran two big Xolair omalizumab trials in kids. One was year-round therapy, the other was seasonal therapy. And what she in effect showed in that was that if you subdivide people based on their peripheral blood dendritic cell interferon response with IgE cross-linking, that people who have very low interferon response are the ones who respond best to omalizumab. So that's part of where this idea of interferon defect being a potential, but we haven't followed up on it. It hasn't been shown in a second study to prove that that's true. So I think it's taking those big clinical studies or some, whether it's the initial follow-up study and pulling out the necessary samples to identify biomarkers. So yeah, we could use it. And because this, I mean, now that we have the other drugs, frankly, I think we use omalizumab a little less in asthma. Although I understand on the pediatric side, that's not true at all. The pediatricians tell me that Xolair is an outstanding drug for kids. It would be so nice, I mean, I guess for drug company people who are listening, if we want to promote anti-IgE as a therapy, if we could fund and find those biomarkers that would really tell us where to use it, where it's going to work better than anti-IL-5 or whatever, that would, I think, revitalize the use of this drug, which clearly does have a utility in asthma, and it's a matter of identifying where that utility is. Anyway, so that's sort of T2 and anti-IgE. We'll kind of come back to that drug as I talk about in the city later on if we have time. But I'll just remind you of the IL-5 story. Again, I think everybody's heard this, but it's always very striking to me. Some people live through it. So, for a long time, people said, all right, Salvay's work and others, the eosinophil is a bad thing, it's a marker of bad disease, and we learned that IL-5 is the key cytokine for eosinophil proliferation and survival, and that it doesn't do much else, and basically it seems you can safely knock out IL-5, get rid of the eosinophils, and it should cure asthma. That was the idea. The drug companies ran 4 studies listed here from 2000 to 2007 in asthma, and they all failed. And as I understand it, the drug was abandoned or about to be abandoned, right? And I think at that point it was acquired by GSK or something. I'm not quite sure the historical logistics of it, but basically the problem was who they studied it in. And I think the hypereosinophilic literature sort of, where it was also being tested, that sort of informed the asthma. I could be wrong on that, but nevertheless, the idea was, well, all right, we have to look at the right type of asthma. Basically these failed studies led big people in the field, including, Bill Bussey here. I picked on him. I picked 2 of his studies, but you read through these, and he was basically questioning a decade's worth of literature of do eosinophils even matter, or was it just a bystander all along, and we were completely wrong to target it. I mean, he didn't quite say that, but that idea that we seem to have failed. And then, they went back and they ran studies in eosinophil-specific asthma, right? These 2 New England Journal studies that people will remember from 2009, and then the Lancet DREAM study from 2012, which turned it on its head. So it said, all right, only take people with eosinophilic asthma, and we can define that different ways, but nevertheless, some marker of eosinophilic inflammation. And suddenly the drugs were dramatically effective. It's why we have the drug today. We could have potentially lost this key pathway and, frankly, set our field back quite a bit. So this is the DREAM study that came out in 2012 that people will remember, and basically it showed that if you're somebody who, so the requirements for inclusion were here, right? So you have to be exacerbation prone, which, as I said before, and I'll show you in a moment, correlates with eosinophilic inflammation. And then they kind of cast a kind of broad net because they weren't quite sure. So you had to have one of these 3 criteria: high sputum, eosinophils, high pheno, or high peripheral. And if that's the case, you move from the blue line down to one of the 3 lower lines, which were the 3 doses of mepolizumab. And so again, basically it reduces exacerbations in half. Now here again, none of these studies, right, they're just population level. So they never really pick out, are there responders, non-responders. I think I would argue in this literature that most people get at least a partial response. And as I'll show you, sort of your level of response correlates with your eosinophil level. But just to again, show some data to the point I made before, that eosinophil levels are a linear correlate of a metric of disease severity, unlike IgE. So what this shows basically is the higher your eosinophils, they're broken down by 100, by every 100, directly associates its blood eosinophils with your rate of a severe asthma exacerbation. Just a more nuanced view of what Sally published in 1999. And furthermore, there's other studies that I could show you that show the same thing with frequency of exacerbations. So the higher your eosinophils, the more frequent your exacerbations. And so there you have both a good clinical and biologic marker of a disease type in asthma. And specifically what GSK went on to show was that when you combine data from their multiple studies, that basically the higher your baseline blood eosinophil count on the x-axis, the greater your index severity of disease. So here, if you're at 1600, right, you have over 3 exacerbations per year, and therefore the greater your response. And there's sort of a regression towards the mean, where you're more severe, you get a better response, and everybody gets down who's treated to sort of a similar level. And basically they get down towards somewhere around 1.5 exacerbations per year. Now the reason GSK ran this study was not because they necessarily wanted to show that association with severity. They wanted to find out what's the minimal eosinophil count to treat. And so they inferred from these 2 studies at 150, right? I mean, the DREAM study was at 300, right? Not 150. But they inferred from this that, if you're 150 or above, you should have a meaningful response. But no question, the people who are much higher in their eosinophil levels are going to have a greater response, are probably more likely to respond, and all the rest. But that's sort of where we get our understanding of this. And the same is probably true, actually. I think Reslizumab has done the equivalent, but it's true with all of the anti-IL-5 biologics.
How about the FeNO? Why they kind of forgot about the FeNO and they kept just pushing like that absolute eosinophil count?
Because the blood eosinophil count, I don't know all the nuances of this data, but what's been summarized to me is that blood eosinophils proved to be a better predictor than anything else, than FeNO or sputum eosinophils.
Does so the FeNO doesn't predict response at all, or?
It certainly doesn't predict it as accurately as blood eosinophils, is what I'll say.
If you go back one slide, when you had 201 to 300 EOs, you didn't have any data, any significance on this slide as far as value of treating. Am I correct?
Well, these are not the same study or the same paper.
Okay.
This is just a paper basically showing that eosinophils are correlate with exacerbation propensity and exacerbation severity.
So treatment's not involved here?
Treatment's not involved here. What you may ask, where did the GSK get those individuals who have lower blood eosinophils? And it's from this, right? So some people had higher sputum or FeNO, but had lower blood eosinophils. And they're basically saying, those people can still respond. So you could have blood eosinophils, and I guess to Taha's point a little bit, you could have blood eosinophils at 150, but really have maybe a really high FeNO, and then you might use the drug. But I would suggest that probably that person, if they have a peripheral eosinophil count of 150, but a FeNO of whatever 80, they may not respond as well as you might hope to this drug, and as we'll come to, you might want to use dupilumab. But again, we don't actually have these head-to-head studies for sure. The only definitive evidence we have is that peripheral blood eosinophils are predictive of how well you'll respond to anti-IL-5. That's the
Is there any kind of predictive model that combine all these variables into knowing how well you respond? I mean, they did all the studies, but they separate them.
I don't know the answer to that. Not that I have used or read about in detail. I assume somebody has tried that. And the summary from that is that just use blood eosinophils.
I saw one paper, they tried a combo of 2 to 5 different markers, and the peripheral eosinophil still was superior. They're as good as adding it. It was kind of surprising that you wouldn't get more discrimination that way.
Yeah, everything. I mean, it is and it isn't, right? mean, the fact of the matter is we don't know exactly what these drugs are doing. We know, for instance, that anti-IL-5 doesn't really drive down sputum eosinophils that well. Maybe that's just, but maybe sputum eosinophils are not the target.
So you mean like in a multi-variable logistic regression model, all the other will be statistically non-significant, only eosinophils probably will be significant?
I didn't run that study, but that's what I would believe to be true, and I think somebody's done that. And I mean, first off, they're all correlated with one another. That's what you would expect. And second, I mean, basically, whenever you run a multivariate model like that, the question is there another piece of data that's adding something that the index variable doesn't? And basically, these don't add any information. The index variable doesn't. They just add noise.
Not to keep beating this subject, but has anybody teased out this data and looked and see if sputum eosinophils correlates with one drug working really well and pheno greater than 50 correlates with another drug working well, and peripheral EOs obviously is the gold standard? Has anybody looked to see if they can stratify it uniquely based on any of those markers?
Yeah, so there was, again, I don't know all these studies off the top of my head super well. I know there was a study that GSK did after this where they looked at not only these, but other things like BMI and so forth, and they basically did almost like a random forest where they're saying, what's the first variable, what's the second variable, and blood eosinophils was the important differentiator for response or not. And the other thing that actually came up, and I haven't seen much follow-up on this, was not not peripheral eosinophils, but BMI, and actually higher BMI went along with response. But I'm sure a lot of statisticians have broken down the data a lot of different ways, and I'm not sure what everyone has shown, but the take-home point is that it's really just blood.
Okay. Makes it easy.
Yeah, and it's right. I mean, as more and more data accrues, like people, you once you start doing secondary and tertiary analyses of data, you got to be a little careful. You can start, leading yourself in the wrong direction. And so,
after your talk at Quad AI, Sally Wenzel, she was talking about a collaboration she was doing with Carnegie Mellon, where they were looking at hundreds of studies combined in a bioinformatics, trying to put all this, and she was clustering them differently. Have you?
I haven't seen that data. I had a lot of issues with what she was proposing, I'll say. Yeah, I mean, right, that's what we do with big public data now, is we try to combine it and look at patterns. And there are pros and cons to that approach. I forget, she pulled some biomarker out of that.
She's talking, she's really hot on 15-lipoxygenase as a...
I mean, maybe, right? She's got some signal there that she needs to follow up, but there's not. You can take look at periostin, right? There was a lot of excitement around that, and it may still come back as a useful marker, but then when that was ultimately tested in a true, clinical study, it hasn't borne out, right? Periostin was not a useful biomarker for. There was a phase 2 study with lebrikizumab where they thought it was, but then it didn't hold in the phase 3 study. So, I think there's a lot of excitement. That's where the research needs to begin. You need to start with some, that's what I'm doing. You need to start with some data, find some potential biomarkers, test them. But, I don't know the details of everything she's doing, but I was perturbed by that, in that, this idea that you just throw a bunch of data in and the computer magically tells you.
Yeah, she only gave us 3 or 4 sentences.
Right, you kind of know
what that data is.
and one of the sentences, I have no idea what this is doing. But it gave me this answer, so. And I would choose not the statistician, that's fine, but.
Max, this is digression. Why is this stuff named periostin? Did it have a bone-related function first?
Yeah, that's correct. I don't know all the details of it, but it was first discovered in bone metabolism, right?
I don't know.
It was, yes, it was, is the answer. And it was subsequently found in the airway. And of course, it has non-bone functions. So anyway, just so I don't want to be biased, obviously everybody knows since then, now we have 3 IL-5 targeting drugs, mepolizumab, reslizumab, benralizumab. I think we all sort of know they're subtly different in how they're administered. And they all work, and they all work about the same. I'm not going to try to say one works better than another.
Matt, I have a question. So I have a very severe asthmatic who's on benralizumab, and he's getting better. The other day, he has no eosinophils in his blood, and yet his pheno was still about 100. Does that make sense?
Yeah, absolutely. I think that's exactly the point, that those 3 things are not perfect correlates with one another. Peripheral eosinophils, blood, and pheno. And we know, I mean, all of the anti-IL-5 studies have shown that, you should completely suppress peripheral blood eosinophils, but you absolutely do not suppress those other 2. And in fact, you still actually have a lot of eosinophils in the lung when you're on one of these drugs, or you can still have a lot. And, there was one study that showed eosinophils in the lung turn off the IL-5 receptor, and that's potentially why. But the fact of the matter is it only suppresses peripheral blood eosinophils to a complete extent.
Actually, I've never seen any data showing that benralizumab and then tissue biopsy obtained. I've never seen such data.
No, so they're running.
They did with mepolizumab, but they never did it with benralizumab. There is
Right.
like with mepolizumab.
So actually, currently, AstraZeneca is doing that. They tried to recruit us as one of the sites to do that, where they want to get tissue biopsies on benralizumab that hasn't been done.
They did have one small study showing a reduction of eosinophils in airway biopsies.
On human?
Human,
Who
just a
benralizumab?
small
What
number,
was
6 or 8 patients.
Yeah, they're trying to enroll. Somebody in the back might know, like 60 or 90 patients or something.
They also apparently at Mount Sinai they demonstrated that in CVID, which is with the GOILD kind of phenotype, that the pheno is actually also elevated in those patients without evidence of peripheral eosinophilia.
Oh,
So
yeah.
so they're
Pheno is not a marker of eosinophilic.
right. That was their point. Yeah.
Pheno
What is it, a marker of
non-specific.
that?
It's a marker of having high exhaled nitric oxide in your lungs. I mean, we don't know, right? We don't know. It's what is the answer. I mean, on the one hand, it's disconcerting sometimes to say, well, we don't know, but I mean, that's the reality with a lot of this stuff, and it's better to admit what we don't know than to pretend that we do. That's my opinion anyway. I'm sure there's a role to play, and I'm sure there's more to learn about it. People do it because it's easy to measure, right? Which is great. We need things that are easy to measure, but we don't have a fundamental understanding of what it's reflecting in the airway. Anyway, so we use these again. I think everybody's aware of this, but currently they're 12 and above, or 18 for reslizumab. This always bothers me, although we're having fewer insurance issues. It's severe asthma. That's not super well defined, but in my viewpoint, it's useful for somebody with frequent exacerbations, basically. And then the current cutoff is 150. Well, it depends on the drug, but my personal opinion is you're much better off in somebody who's 300 or above, and the higher the better. And again, same idea with omalizumab. It works, but it certainly doesn't cure the disease. It decreases exacerbations. On average, if you kind of take all the studies, these people still have about 1 exacerbation per year. And I think we were like, oh, this is great, but there's room to be better. Does all these other things, decreases steroid use, improves quality of life, and it may augment FEV1. I think it depends, right? We see in some people there's a clear improvement in pulmonary function. In some people there's not. And again, here we do have a good biomarker, peripheral blood eosinophils. That's the take-home point, I think. So then, again, this is sort of what I forget if I presented this in Alaska or in Quad AI, the idea of, well, what's next? We've got IgE, we've got eosinophils, we know about IL-5, and of course, what was next was IL-4 and IL-13. Everybody is sort of aware of that. There's been a lot of work with dupilumab and izumab, and of course, we now have dupilumab approved as of mid last year. what is it? Well, it targets the IL-4 receptor and thereby blocks, both canonical IL-4 and IL-13 signaling, as shown here, which both use the IL-4 receptor. And this was the New England Journal paper that came out at ATS last year that basically showed it. As with all these studies, they use exacerbations as the primary outcome. And as with the other studies, it basically decreased exacerbations by 50%. And in this case, every study is a little different from the other, which is good and bad. But here, rather than 2 exacerbations per year as an enrollment criteria, they just had to have at least 1. But nevertheless, they saw sort of a similar efficacy of decreasing in half. They did within this study show some improvement in pulmonary function, albeit somewhat modest. And again, I think there's very individual to individual variability. And then here was one of one of the things they were particularly happy about was that yes, eosinophils, blood eosinophils are a good biomarker. And the higher your blood eosinophils, the more likely you are to respond, or the better your response. That's what's shown in the middle area there. But also, independent of blood eosinophils, as a univariate analysis of FeNO, they saw that high FeNO, right, 50 or above, or 25 to 50, also is an independent predictor of response. So this gets to the fact that these things can be associated, but they're not completely. And the idea that probably this is a useful biomarker. I haven't followed it, and I'm not sure how many additional studies of this have occurred yet to kind of prove this is true and that it's not. I mean, I don't remember. I think Mario could tell us, specified this as an analysis. I'm sure they did it. They specified this as a pre-analysis. But nevertheless, when you think about subgrouping within a randomized controlled trial, it's not ideal. So you'd like to see this proven in a second study as well. But for the moment, we can certainly use FeNO or think of FeNO as a useful biomarker.
But you can't get it approved just on a FeNO value. You have to have...
Well, they still have to have exacerbation from asthma, yeah. I mean, you have to have the clinical criteria and then think of the biomarker. So, I mean, where does that currently leave us? Well, this is all that we currently have, right? There's nothing more, despite all the ongoing research. We have, and I added AERD here always because I think it's a very useful one to keep in mind, but we have T2, severe asthma, where we have a binary biomarker of IgE. It's not a continuous, it's not a great predictor, and we have anti-IgE or allergen immunotherapy, and then we have high blood eosinophils for anti-IL-5, anti-IL-5 receptor, and high FeNO, or high blood eosinophils for anti-IL-4 receptor alpha. Aspirin exacerbated respiratory disease, I'll just mention there is no biomarker, right? Boston groups and others have spent a lot of time looking at urinary LTE4 and other things. They're decent, but they don't do as good a job predicting as the clinical phenotype does. So you're better off relying on the clinical phenotype of nasal polyps and sensitivity if you want to treat for AERD, in which case you sort of have those 3 things to pick among: leukotriene, aspirin, desens, and actually there is no data, but possibly anti-IL-5. And then again, this is just for those people who want it all in one place. These are the different aspects of the 5 drugs we have approved. I'm not going to go through it, but you can see there are subtle differences. So then we're left with, well, okay, great. We have those. There's still a lot of unmet need. So we have T2 asthma, IgE. We have eosinophilic asthma. There's an overlap. We have anti-IL-5, anti-IL-4, 13. And what else? And of course, I think a lot of people know that probably what else is in the pipeline are the epithelial-derived cytokines. And, that there's now data around TSLP in the phase 2 study. So this was Jonathan Corin's study in the New England Journal, looking at anti-TSLP, and the excitement being that he defined people based on blood eosinophils pheno, sort of the known biomarkers that we have, and then just sort of a composite score of T2 status, and we showed that this, in a phase 2 study, appears to be effective in T2 low. Now, this is great. I'm not dismissing this at all, but I think ultimately defining disease by presence or absence of T2 is not a good way to go, right? We really want more detailed, we want to know what is T2 low, not that it is T2 low. But as a starting point, this may have efficacy in a broader range of individuals or a different subset rather than a highly overlapping subset of individuals with asthma. And there's work ongoing for this sort of approach. But in our last 10 minutes, let's talk about the other stuff, the stuff I'm more interested in, more familiar with, which is how do we really advance the field, how do we learn new stuff, and basically this idea of personalized medicine and better, new, better biomarkers. And I'll just sort of talk you through the type 1 interferon story first. And there's a lot of conflicting literature here. In whatever this was, 2005, Peter Wark's group gave us this canonical finding that in asthma, the interferon response is defective. And he took airway epithelial cells, grew them in a culture, not at a air-liquid interface, and showed in whatever it is, 14 people, that there seems to be a defect in interferon response to rhinovirus. And that seemed great. A new issue that we can treat. Specifically, the treatment for that would be replace interferon. That study was run and failed. So inhaled interferon beta as a treatment. Now, there are a lot of reasons that study may have failed, but and we can talk a little bit about that, but basically they showed that in a group of adult asthmatics that there was no difference between inhaled placebo and inhaled interferon in what was their primary outcome, ACQ6. They did show, maybe in a subset of individuals, you could, in what they defined as difficult to treat asthma, but it's always, again, problematic when you start subgrouping, especially when you're in a small study to begin with. And so that is currently, to my knowledge, not being pursued. The drug companies sort of killed that.
Shown that was potent in some animal models or some other disease state? How good is that as a drug?
Well, interferon beta, yes, it's a potent drug. It's been used. It is actively used in other diseases like MS, right? I don't know what animal studies in asthma were done prior to this. It's a good question. I don't know how many. I don't know much about asthma, about mouse models of asthma. I know the basics, but I don't know that anybody's built an interferon deficient mouse model of asthma and tried this.
Because why interferon beta? If you look at the viruses, I will look for gamma, trying to get the virus.
So it's type 1 interferons, which are interferon alphas and interferon beta, are what are the response to respiratory viruses. And Peter's work specifically showed a defect in interferon beta production. There was some evidence maybe of interferon alpha defects, but it's not interferon gamma. There's no defect of type 2 interferons. It's type 1 and type 3. Anyway, but the point I would make from this is if they maybe subgroup and said, I'm only going to take people where we can demonstrably show that they have an interferon defect at baseline, that they may have had a successful approach. If they had, just like with eosinophil targeted drugs, if they had, rather than taking asthma writ large, if they had subgroups, because I'm sure there are some asthmatics who have a defective interferon response, and there are a lot who don't. And that's exactly the issue, and that's what some of our studies, frankly, every piece of data I've looked at, we largely see the opposite. You see an excessive interferon response in asthma. And a lot of follow-up studies, Peter's work, showed exactly that. So this was our Jackie paper last year that showed actually in response to RSV, you see an augmented production of interferon beta in some people with asthma, And other asthma, you see it equal to healthy controls, or actually here it is modestly lower at the protein level on the right. But the idea that there are some interferon overproducers and some interferon underproducers, and you need to separate those out. And in this study, we said, well, it seems to roughly associate with fixed obstruction or not. That has not been borne out in our subsequent work. It's probably genetically controlled. I know Jason Devley's doing some work on that now. But again, the idea that there's probably a role for interferon to play, but it depends on who. This was the Inner City Asthma's take on interferon. So this was, they had two big studies of omalizumab in kids, and basically showed this really nice curve on the left where, really, with asthma, especially in kids, you have these seasonal exacerbations in the fall and the spring. And treatment with omalizumab certainly doesn't cure disease, right? None of these go down to zero, but it basically gets rid of these seasonal exacerbations. They did a second study that showed if you only give it during the fall before kids go back to school, you get the same effect, so you can kind of use it more sporadically. And what Michelle Gill's group that I alluded to before showed was basically, it's a little complicated study, I'm not going to go through all of it, but basically if you take PBMCs or purified peripheral dendritic cells and you simulate IgE cross-linking with rhinovirus, that omalizumab recovers the interferon response to rhinovirus. So these are kids who were treated with omalizumab, and post-randomization in dark blue, you see a recovery of their interferon response that's not there in placebo, to that idea that maybe the people who are best responding to the drug are those who can recover an interferon response with omalizumab, which speaks to the idea that, well, maybe Xolair's not getting rid of IgE, or that's not the primary way it's effective, or that has a secondary effect of augmenting interferon response. I'm out of time. Everything else is just a bunch of complicated heat maps and stuff anyway. So if people want to talk through these network studies and everything, and this is what Sally's trying to do as well, we could, but I guess for the sake of time, I'll just mention a few so you've heard them, right? One really people are really excited about is IL-6. So in adults, the SARP cohort and UCSF has suggested that IL-6 may be a good biomarker of obesity-associated asthma. Generating targeted, a lot of potential problems with that, but an interesting idea. We've got a paper where we've shown a whole bunch of other pathways that change. So this is our IL-33 pathway, but we also have SMAD3, which is this network of genes related to TGF-beta signaling being very relevant to exacerbations. And there's a lot of, I would say, pretty sophisticated approaches going on of trying to leverage big data in a very well-controlled experiment, a human experiment, to determine what are our next pathways. So with that, I'll just remind you that asthma, right? Same idea. We learned T2, but then some here we took a step back, like we learned about eosinophils, but then we forgot that we have to endotype. Then we learned how to endotype. That recovered the IL-5 approach. We've had emergence of biomarkers, but then sort of plateaued. We don't know what to do with some of them. Anyway, up and down and up and down. And the goal is to move generally forward. That line actually moves back in time, so we can't do that. But anyway, to move towards personalized asthma management.
You have me a little confused about interferon. One study showed it was down, and you had a study that showed it was up.
Yeah.
What are we to believe?
Both. And we have to figure out who's who.
Can you quickly?
I don't actually think it's down. I'm pretty biased against that idea. I don't think that's been recapitulated in many studies at all. But they're certainly lowish to normal, and there's high.
Your interferon data is very suspicious for the people that just have peri-infectious asthma and they really don't have asthma except with viral infections.
Yeah.
It would be interesting to study their interferon response because that would be the study population you'd think would show the biggest variability there.
I completely agree. And we actually have some of that data where we've in effect shown, we have a nice Kaplan-Meier curve that shows at baseline, Jamie is involved in some of this. It's not a perfect study because the study wasn't designed for this, but baseline lower basal airway interferon expression associates with higher risk of exacerbation in the short term. But those same people actually have an excessive interferon response during viral exacerbation. So they sort of bottom out and then overcompensate. But until somebody does really good time series studies, we won't actually know what's going on. Seb Johnson's group in the UK is doing a little bit of this, but it's viral inoculation and it's in mild asthma because you can't give viruses to severe asthma, legal or whatever. So we're trying to get that time series data in more severe asthma.
So you mentioned really briefly lung resident eosinophils being able to downregulate with the IL-5 receptor. Is that is it any lung resident in the eosinophils? Is it a specific subtype? Or is
I know there's one study that's shown that, and Bill Bussey really likes to talk about it, which is why I ended up talking about it. It hasn't been shown broadly, and to that point, right, we think of eosinophils as all the same. That's not true at all. You can look at the Boston Nature paper from last year in nasal polyps, right? You see different subtypes of disease by single cell RNA sequencing. The same needs to be done in pulmonary, in asthma, where we actually understand the heterogeneity of cell types. Some will have IL-5, I'm sure, a receptor, and some will not.
Okay, thanks, Matt. Jonathan Cora, who you referenced and is doing some exciting work, is going to be in town in a couple of weeks. He'll give Journal Club here, so encourage you to come and pepper him with questions as well.
Exactly, yeah, that's what I'm thinking. Because you got all the mucus,
Yeah.
and you got airways, diverted, and how well does that stuff penetrate?
Exactly.
I mean, just, how good, that's what I was wondering, how good a drug that is.
Where does it have to go and how does it get there?
I mean, would you have to nebulize it under positive pressure, or what would be the, I mean, just one puff of it, I mean.
Good, thank you. I'm not off at left field here.
Yeah, I mean, just thinking,
Yeah, okay. Great.
it just, you just can't,
Yeah.
can't say that the pathway is not going to be important just because we're not
I mean,
checking
it's
it.
cellular.
I don't have any experience with drugs. Have you ever?
No. I've got retired from the. I don't even know the names of these things. That's why I keep having
Anybody want some more food before I
Sure,
close?
sure.
You can take some home.
Yeah.
The way you,
I'm going to register.
yes, so, China, you need to get, so, you know how they have to be like,
So we're talking about
China, you can change, all you have to do is change the, but I mean, I can kind of into that.
To,
Okay.